Firstly, what's the difference between clear versus clean water?
जो पानी साफ दिखता है इसका मतलब जरूर नहीं हो साफ हो, उसमें बहुत सारे वायरस कीटाणु वगैरह हो सकते हैं।
Clean water is also water that is clear, but I feel like not all clear water might be clean. Clear water might not be safe to consume.
पानी तो एक ही जैसा रहता है।
Are plastic water bottles safe to?
प्लास्टिक में पानी बहुत होता है, तो मेरे ख्याल से बहुत सारे केमिकल्स होते हैं जो हमारे बॉडी के लिए अच्छा नहीं है।
I don't know if it's the best thing to do because obviously it has environmental ramifications to it. I guess it depends on your definition of safe.
I don't think that it is good.
No?
Not sure. ये सकते हैं।
And lastly, is rainwater drinkable?
क्या है वजह, लेकिन शायद गंदा हो सकता है। ये रेन डायरेक्ट ऊपर से आते हैं तो बहुत सारी चीजें बीच में उनको मिल जाती हैं।
I'm sure it's not in large quantities because the evolution is ridiculous.
Yeah. It's supposed to be pure, but I think it like absorbs the impurities from the atmosphere or something.
At the end, we will answer these 3 questions. Right now, let's talk about clean water. To do this, we're going to make a homemade water filter and discuss each of the layers. So before we make the filter, let's test the quality of some other samples of water. So this is filtered water from home, this is bottled water, and this is tap water. This is called a TDS meter, which stands for Total Dissolved Solids. What this tests is it tests the parts per million of different particles that are in the water. The TDS reading at home is around 42, bottled water is 51, and tap water is 91. From these readings, these could all vary depending on what kind of a filter you have at home or what kind of bottled water you're using. However, what we can see from this is that filtered water at home is the best for you. It has the lowest reading, which means it's the cleanest water to drink. After that is the bottled water. While this is only 10 parts per million higher than normal water, this still has other environmental implications through the use of plastic, so it's better to stick to filtered water if possible. And lastly, there's tap water. This reading is a lot higher, and it contains various bacteria which aren't good for humans to consume. These 2 things tell us that you should not be drinking tap water. To make this filter, we're going to start with the filter paper. We're going to put this at the bottom. We're going to keep the paper in there, and now I'm going to tape the paper along the sides. Now that we have the filter paper taped in on the inside, we're going to add some cotton balls so this can absorb the water. Next, we're going to put in charcoal dust. Next, we have coarse sand. Next, we're going to be putting some rocks. Now, this is our entire filter. So here we've simulated river water. If you look closely, it has some leaves at the top, cloth, there's some other dirt particles, random things in it, which are all pieces and particles that you could find in an actual river here. These are all accumulated partly by humans and partly by sewage systems that are being directed into the rivers that we have here. We're going to test the initial TDS reading for it to test how bad the water is, and then after this we'll put it through the filter and see if it improves. Here this is going to be a value of 697 parts per million. Anything above 500, very bad, it's very toxic, you should definitely not be drinking it. Let's see if it gets better after we put it through our filter. Now it's been about 20 minutes, we're gonna check the TDS quality, but before we do that, let's take a look at the filter. If you look on top, you can see that all of the bigger leaves have been stuck on top. Down here at the water, none of the smaller particles are still visible. They've all been stopped somewhere here in the filter. Wow, the reading is down to 176, which is incredible. It's decreased by almost 550. We had 706 the first time we looked at it, which means this water is a lot better for you. Taking this water, it's still not drinkable, but what you could do is you could sterilize it first, boil it or heat it up in some way. So that's one method of getting rid of the other chemicals and bacteria that can currently be in this water. Another way of using this water as it is right now is for bathing or washing clothes. What's the science of water pollution? From our experiment, we see that our water resources like rivers and lakes are being heavily polluted. Using even simple filters can help improve the cleanliness of our water. How else can we test our water? And how can we spread awareness of the causes and impact of water pollution? Like TDS that we measured in the experiment, there are a number of other tests, including chemical and biological tests to measure water quality. Many pollutants are microscopic in size, so one indicator of pollution is coliform. Most coliform bacteria are harmless, but coliform is an indicator of potential environmental pollution. A subgroup called fecal coliform can be very harmful. harmful. And you may have heard of E. coli, which is a dangerous subspecies that can cause gastrointestinal issues, typhoid fever, hepatitis A, and other complications like kidney failures that can lead to death. Just because water appears to be clear doesn't mean that it's safe to drink. In our experiment, we managed to bring the TDS levels down substantially, but we'd want to also boil the water to eliminate any fecal coliform bacteria that might be present. Fecal coliform microbes are rod-shaped bacteria that originate from animal or human feces. They're measured in a unit called MPN, which stands for most probable number. Ideally, drinking water should have 0 fecal coliform, but a maximum of 50 MPN per 100 ml is usually permitted. However, findings have shown that actual MPN readings in many rivers are at extremely dangerous levels. In India's holy Ganga River, readings have exceeded tens of thousands of MPN, and even as high as 200,000 MPNs. This is extremely risky, both for the millions of people that directly bathe in the Ganga each year, and because it's far exceeded the level considered safe for agricultural use. We know that over 450 million people depend on the Ganga for part of their food supply. How did rivers become so polluted? Water provided the beginnings of life on our planet. Today, the Earth has about 70% of its surface covered by water. 97% of that is salt water in our oceans. Of the less than 3% that is fresh water, nearly all of that is locked up in ice and in the ground. In the end, freshwater lakes represent only 0.007% of the total global water supply, and rivers only 0.0002%. And yet we treat our water as if it's unlimited. In prehistoric times, humans settled by riverbanks, which provided fish to eat and water to drink, cook, and bathe. Thousands of years ago, these settlements grew in numbers as ancient groups learned how to grow crops using irrigated water and nutrients provided by rivers along floodbanks. Civilization flourished along the Nile River in Egypt, the Indus Valley in India, the Euphrates in Mesopotamia, and the Yellow River in China, with easily accessible water. But as our populations have magnified, many of our most critical water sources have declined. There are 2 factors adding pressure. First, our supply of clean water is declining as we heavily pollute water bodies and suffer the effects of climate change as more rivers are drying up. And second, our demand for water continues to expand rapidly as our population approaches nearly 10 billion over the next few decades, and urbanization stresses our aging pipeline infrastructure. Let's examine the impact of water pollution. Our water supply is being stressed by both reduced supply and increased demand, which is the worst of both, and we can see the effects already. Billions of people live in water-scarce regions, and 1 in every 9 people on our planet lack access to safe drinking water. That's a basic human need: food, shelter, and water. 80% of our global waste flows right back into rivers without being treated, and in some lesser developed countries, that figure is 95%, according to the United Nations. Every day, 2 million tons of sewage and other effluents drain into the world's water. Take India. Over 1 billion people depend on India's 14 large river systems for their food and livelihood. Yet 764 grossly polluting industries were found to be discharging 500 million liters per day of effluents into the Ganga River. And just the 22 kilometers that the Yamuna River passes through Delhi accounts for more than 70% of its pollution. The Indian government estimates that about 62 billion liters per day of sewage are generated in urban areas throughout the country. But India has capacity for sewage treatment of only about 1/3 of that. The rest, unfortunately, much of it is flowing into our rivers, heavily polluting them, killing our fish and biodiversity, and adding toxins back into our food as agriculture uses more of our water resources. Most people think clean water is an issue that other people face, but nearly every part of the world is being affected by water. Even in the United States, the Environmental Protection Agency, EPA, estimates that half of all our rivers and streams are polluted and unfit to drink, and 1/3 of all lakes are unfit to swim in. Hundreds of millions of people risk their health each day eating food produced in agriculture that uses untreated wastewater. Unsafe water kills more people each year than all violence combined. Like the impact on humans, water pollution can also harm fish, other animals, plants, and the biodiversity of our water-dependent systems. Polluted waters can harm our beaches and our agricultural production. Water is something that all living organisms depend on in order to survive. So in the comments down below, let me know what your thoughts and ideas are on what we can be doing to help solve this problem. So what's preventing change? Unfortunately, one study found that 40% of adults worldwide have not even heard of climate change. And in developing countries like India, that number can rise to about 65%. Plus, there are many vested interests and misinformation about the scientific validity of our environmental impact. So how can you help make an impact? Psychologist Nathaniel Branden wrote, "The first step toward change is awareness. One simple step you can take today is to spread this video to raise awareness of climate change. Spread awareness. Spread science with impact."